Okay, a few examples on infinite geometric series. So let's take a look, and then that will be the end of 11.2. So let's look at 23 on page 748. We're given 3 minus 4 plus 16 divided by 3 minus 64 divided by 9, and so on and so forth. The question is asking us to determine whether the geometric series is convergent or divergent. If it is convergent, find its sum. So first of all, we are going to look at the common ratio, and you see it's a negative number, but it doesn't matter. So I'm going to divide 64 over 9 by 16 over 3. Yes, I'm going to put minus in front. It matters, of course, but we are going to realize that when we flip 3 over 16, and this is 4, and this is 3, this is negative 4/3. If you remember, r in absolute value has to be less than 1, and this is not less than 1, is over 1 or negative 1. It's outside, so this is less than negative 1. So the geometric series diverges. Why? Because it will converge only if the common ratio is in absolute value less than 1, or in other words, if you can remember it like this, same thing. Next question, 25, on the same page, 748. We have 10 minus 2 plus 0.4 minus 0.08 plus dot dot dot. And let's determine here the common ratio. So I'm going to divide negative 0.08 by 0.4, and we get negative, we multiply top and bottom by 100. So this is negative 1/5, because this in absolute value is less than 1. Negative 1/5 in absolute value is less than 1. Then we know that the geometric series converges. And very simple, in determining its sum, it will be a divided by 1 minus r. So a in our case is 10. 1 minus r is 1 plus 1/5, because it's negative, careful. So 10 divided by 1, and this is 9 over 5, and changes into 5 over 9. I'm sorry, 6, of course. 5 plus 1, 6. Oh, oops, 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 oops. So 6 over 5, so it becomes 5 over 6. I'm not sure how the 9 got in there. It's removed. So we'll simplify by 2. So 25 over 3 is the sum of this convergent geometric sequence. Of course, geometric series. Good. Moving on. Next example. What was it? 27. Also on 748. And we have the sum from 12.73 to n minus 1 from n equals 1 to infinity. As we see here, this is the a and this is the common ratio. Since the common ratio is 0.73, which in absolute value is less than 1, the geometric infinite series converges. So in order to find the sum, so remember the sum is a over 1 minus r. So a is 12, 1 minus 0.73, so it's 12 over 0.27, and we can calculate that. 1200 over 27, and I will simplify by, what can I simplify by? By 3, yes, of course. So 400 over 9. Moving on to 29 on 748. Let me move this out of the way. So here we have the sum from n equals 1 to infinity, from negative 1 no, I'm sorry, negative 3 to n minus 1 divided by 4 to n. So careful in this case, we have to make sure that we rearrange this fraction in this format. N equals 1 to infinity. I will take 1/4 in front, and then I have negative 3 to n minus 1 over 4 to n minus 1. So negative 3/4 to n minus 1. And this is clear now. The common ratio is negative 3/4, which in absolute value is less than 1. So the series converges. So in order to find the sum of the series, we have a, which is 1/4, and we have to divide by 1 minus r, but r is negative, so plus 3/4. So the top is 1/4. So here is again 7/4. So times 4 over 7. So the sum is 1/7. Good. Moving on to 33. On the same page, 748. And we have determine whether the series is convergent or divergent. If it is convergent, find its sum. So we have 1/3 plus 1/6 plus 1/9 plus 1/12 plus 1/15 plus dot dot dot. Okay, so notice that we can factor out 1/3 from this whole thing, and we get 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 5 plus dot dot dot, which this is basically 1/3 outside, and the sum of 1 over n as n goes from 1 to infinity. N equals 1, n equals 2, n equals 3, and so on and so forth. We know that this is the harmonic series and this is divergent, and this is a multiple of the harmonic series, so obviously it is divergent as well. Okay, moving on to 45. On the same page, 748, and we have the sum from n equals 1 to infinity from natural log of n squared plus 1 divided by 2n squared plus 1. Okay, so we know that this limit of natural log of n squared plus 1 divided by 2n squared plus 1 as n approaches infinity. You see, again, by the same procedure we use, the L'Hopital's rule, the limit inside is 1/2, and this is natural log of 1/2. Well, this is not equal to 0. So by the test of divergence, this is divergent. Good. Let's take a look at 54 on the same page, 748, and we have 46, which we know this is 0.46, which is 0.46, 46, 46, and so on and so forth. So the question here again, express the number as a ratio of integers. Okay, so that's our first step. How do we do this? Well, 46 over 100 plus 46 over 10,000 plus 46, I'm adding 2 zeros, plus 46, I'm adding 2 more zeros, and so on and so forth. So obviously this is 46 over 100, 1 plus 1 over 100 plus 1 over 10,000, and so on and so forth. As you see, this is a geometric series, and it is convergent because the common ratio is 1 over 100. And what is a sum? The sum will be A, 46 over 100, divided by 1 minus 1 over 100. So 46 over 100 times 99 over 100, so 100 over 99. So the answer is 46 over 99. As we knew from arithmetic, like a long time ago. Okay. One more example let's look at, 61, and this is on page 749. So this is a very important type of example. Find the values of x for which the series converges, and then find the sum. So we have the sum from n equals 0 to infinity, from x minus 2 to the nth power over 3 to the nth power. Okay. So they ask us to find x for which this converges and also find the sum. Okay, so first I'd like to see what is happening here. So I will first rewrite it as n equals 0 to infinity from, x minus 2 over 3, everything to power n, they have the same power. Now let's just take a look for a second and see what happens. When n is 0, this is 1, plus when n is 1, x minus 2 over 3, plus when n is 2, x minus 2 over 3 squared, plus dot, dot, dot. It's very clear that the common ratio is x minus 2 over 3. If this expression is not less than 1, the infinite or the geometric series or the infinite geometric series will be divergent. So this must be our condition, our starting point. In order to solve this inequality, we have to rewrite it as x minus 2 over 3 less than 1. We will multiply all three sides by 3. We will add 2 to all three sides. And remember, we did this in epsilon delta definition, if you remember from Calc 1. The absolute value of x has to be less than 5. If we consider less than 1, we are missing possibilities for x, so that will not work. Okay, so the absolute value of x has to be less than 5. If that's the case, now what is the sum? So for x less than 5 in absolute value, then the series converges. Good. So now what is the sum? I didn't mean to write that. I meant to write s, of course. The formula, I'm going to write the formula one more time, but we already know that. There is no need to write it again. I can still put it here for you to see it. So s equals a over 1 minus r. Good. So now let's determine a is 1, and 1 minus the common ratio, which is x minus 2 divided by 3. Okay, so what do we get here? It's 1 over 3 minus x plus 2 divided by 3. Finally, we flip, so this is 3 over. So 3 plus 2 is 5, 5 minus x. And this is the sum of the convergent geometric series for x less than 5. And of course, it comes from the common ratio being less than 1. Thank you. I hope this helps.